In this video, we're going to look at what's called ionic nomenclature, or in other words, how to name things. Specifically, how to name ionic compounds and write formulas for ionic compounds. So we're going to look at both going from formulas to names, but then also we're going to look at going from names back to formulas. We're going to start with the easiest, going from our formulas to our names. The example that we're going to use for this first one is NaCl. And I'm going to use this as an example to go through the steps for how to turn this formula into a name. So the first step that we're going to do is write the name of the metal. Okay, so I have a metal and a nonmetal. My metal is Na. I know that from the periodic table, the name of that is sodium. So there's my first step. Just going to write the name of the metal. Metal is sodium. Second step, write the name of the nonmetal. Cl is chlorine. And then my third step is to change, oops, misspelled that, change the end to IDE. So I'm going to take chlorine, that's at the end, and I'm going to take off the ending, and I'm going to change it to IDE. So NaCl becomes sodium chloride. So I just followed my three steps, write the name of the metal, write the name of the nonmetal, change the end of the nonmetal to IDE. Nice and easy, okay? So we're gonna look at a variation of this. And that is when our metal is a transition metal. So the example that we're gonna use for this one is FeCl3. Okay, so I have my list of steps and I'm going to use this as my example to write the name. So the first thing is to write the name of the metal. So Fe is iron. Okay, so far it's exactly the same. The step two, determine the charge of the metal. So because this is a transition metal, and transition metals can have variable charges, we need to determine what is the specific charge of this metal. And this is where this gets a little complicated. We're going to determine that by looking back at our formula. So our chlorine has a -1 charge. So one chlorine ion has a -1 charge. So a reminder, on your periodic table, the first column of metals has a +1 charge. Then it goes +2. The transition metals are variable, so we skip that one. Then we have a column where it's +3. This column here, where it goes between nonmetals, metalloids, and metals, can be plus or minus 4. Then we have -3, -2, -1, and a charge of 0. So since chlorine is in this last column over here, it has a -1 charge. Okay? If I have 3 chlorines, because that's what this little 3 means, I have a total of -3. Now, if you remember from ionic bonding, we need to have a neutral compound, okay? So if chlorine has a -3 charge, my iron has to have a +3 charge because I only have 1 iron, so my 1 iron has to have a +3 charge. So that's the hardest part of going from formulas to names for transition metals, is to figure out what that charge is on the metal. To help you with this, on the back of your periodic table, there is a table that has the common transition metals and their charges. So this gives you some likely options. So from here, we determined that iron had a +3 charge. On my table, it says that iron is likely to have a +2 or a +3 charge. Those are its common charges. So you can use this on the back to kind of give you a little bit of guidance. Okay, so now that I've determined the charge of the metal, I need to write that charge as a Roman numeral. The Roman numerals that we're likely to use are 1 through 8, and I have them written here. So I have the regular number on the left side and then the Roman numeral on the right side. So the Roman numeral for 3 is 3 vertical lines, and I'm going to write that Roman numeral in parentheses. Okay? And then number 4, write the name of the nonmetal. Cl is chlorine. And then my last step is the same as the last time, change the end to IDE. So I'm going to change chlorine to chloride. And so I have iron 3 chloride. So the only major difference with transition metals is we have to figure out the charge on the metal, and then that charge on the metal goes into parentheses here in the middle. So what's in parentheses in the middle of this name tells us the charge on the metal. This only applies for transition metals. If it's not a transition metal, so if it's not in the middle here, it doesn't need a Roman numeral. Okay, let's look at how to go from names to formulas. Okay, to go from names to formulas, we need an example to start with. So let's start with, let's do magnesium bromide. Okay, so MgBr2. And I just told you the name, but we're going to walk through the steps so we can figure out how to name it. So the first thing is to determine the charges of the metal and, oops, totally messed that up. I just gave you the answer. Even though I just gave you the answer, we're still going to use this as our example because it's a good one, okay? So the first thing that we need to do is determine the charges of our metal and our non-metal. So our metal comes first, our non-metal comes second. So if I'm looking at my periodic table, the charge on magnesium, so if I go and find magnesium, magnesium is here in the second column, so it has a +2 charge. And then bromine is in the last column before the noble gases over here, so it has a -1 charge. So I determine the charges. My second step is to write the ions. So I'm going to come over here and I'm going to write magnesium with a +2 charge and bromine with a -1 charge. And then I'm going to do something that's called crossing the charges. So what I'm going to do is I'm going to take my charge from magnesium, it's a superscript right now, and I'm going to turn it into a subscript on bromine. And I'm going to drop the plus. So I'm going to turn this into Br2, and then I'm going to take my charge from bromine and turn it into the subscript on magnesium. So it's just going to be Mg, because we don't need the 1. So my 2 came down here to bromine, and my 1 came over here to magnesium. And then the last step is to reduce if needed. So this is a 1:2 ratio. I can't reduce that any farther, so I don't need to do the last step. So this is my formula for magnesium bromide. Now, an example where you might need to reduce is, say for example, you have tin with a +4 charge and oxygen with a -2 charge. When you cross those, you end up with tin with a 2 subscript, O, or oxygen, with a 4 subscript. This is a 2:4 ratio, so we can reduce that to a 1:2 ratio. So if you can reduce them, you're going to. If something just has a 1, you're not going to be able to reduce it, so you just leave it as it is. So that's how we write names and formulas for ionic compounds.